You look at what computers are able to do, and they can do incredible things, and yet all they really do is add and multiply. So how do they build up such incredible things from such simple steps? The secret? Algorithms. Algorithms are procedures that follow one step after another, and the two key pieces that make algorithms able to do such interesting things are branches and iteration. Branches are decision points where the algorithm might do one thing or it might do another thing. And iterations where a procedure happens over and over. Branching is the topic that we'll mainly focus on in this presentation. This Scratch project has a welcome screen that says press, tap, or hold the space bar. And when you click the green flag, you briefly get a picture, and then that sprite zips off to the left. If I hold down the space bar, it comes back to the right and wraps around. And as soon as I let go of the space bar, it goes off to the left but gets caught there. What is going on? It's all in this script right here. That wonderful behavior you saw in the Scratch program is just following this algorithm. Its main component is a loop, where it iterates forever. Over and over and over, it does two things. It has this if-else structure, and then it turns 5 degrees. Then it does it again. An if-else structure, turn 5 degrees. An if-else structure, turn 5 degrees. An if-else structure, turn 5 degrees. Each iteration is an if-else structure, turn 5 degrees. This presentation will mainly focus on that if-else structure. The branching part of an algorithm comes from the if-else structure. If-else structures have 3 parts. The third part isn't always there. The first part is this conditional, in Scratch a hexagon-shaped question. The second part we call the if chunk of code. The third part, which is the part that's not always there, is an else chunk of code. Sometimes I think of a fourth chunk of code that happens after the if-else structure, but it's not really part of the if-else structure. It's just important to remember that something's there that will happen after the if-else structure is done. So let's take a look at the conditional part. The conditional is a Boolean expression. It's evaluated by the computer when the computer first reaches the top of the if-else structure. If the Boolean expression, which by the way means that it has to be true or false, if that Boolean expression is true, then the computer proceeds to execute the chunk of code in the if chunk. If the Boolean expression is false, then the computer executes the else chunk of code. Either way, the computer continues with the chunk of code that comes after the if-else structure. Once the computer has evaluated the conditional Boolean expression and decided is it true or false, the computer will execute one of these 2 chunks of code. If the conditional was true, the computer will execute this chunk of code. If the conditional was false, the computer will execute this chunk of code. The computer will always execute one or the other. Never does it execute both chunks of code. Never does it execute neither chunk of code. It always executes one or the other in an if-else structure. Now it is possible to leave off the else, to have just what's known as an if structure, like this one right here. Then, if the conditional is true, the if chunk of code is executed. If the conditional is false, nothing in the structure is executed, and the computer proceeds with the next instruction. The red chunks of code in these 2 figures shows you the if chunk and the else chunk in an if-else structure. After an if-else structure finishes executing the if chunk or the else chunk, the computer continues with the very next block. That happens whether or not the if chunk happened or the else chunk happened. So no matter whether that conditional is true or false, the very next block will execute. If the conditional was true, then the if chunk executes, and then program execution continues after the if-else structure. If the conditional was false, the else chunk executes, and then program execution continues after the if-else structure. Either way, this turn 5 degrees would occur, whether that conditional was true or false. That's why the face sprite spins, whether it was going to the left or the right. No matter whether the conditional is true or false, eventually execution will continue after the if-else structure. If the conditional is true, the if chunk executes, and then execution continues with this turn 5 degrees. If the conditional is false, then the else chunk executes, and then execution continues with this turn 5 degrees. Either way, this piece of code here, the turn 5 degrees, will occur after the if-else structure. The title about algorithms suggested that this presentation was about both branching and iteration. So I'll just mention that Scratch provides a few different ways to iterate. One, iterate forever. Just keep doing what's inside this forever block. Another, repeat a specified number of times, and you can set how many times. You can even make that a variable that calculates how many times to repeat. You can also repeat until a conditional is true and then quit repeating.